Welcome to my presentation on visualizing hypothesis testing. My name is Moise Esunga. The agenda. I'm going to cover 4 visualizations. Visualization for the test for a mean, visualization comparing two groups, visualization of efficiency comparison, and visualization of a correlational test. I will conclude with the takeaway of my presentation, and then I will be open for questions. Visualization number 1, test for a mean. On this graph, x-axis represents the number of defective widgets out of 100. Y-axis represents the probability of defect, and we have a bell curve. The highest point on the bell curve corresponds to the mean. The research question: on average, are the widgets from Acme Widget Company defect-free? The null hypothesis: the average number of defective widgets equals 0. The alternative hypothesis: the average number of defective widgets is greater than 0. Looking at the graph, the highest point of the bell curve has a 0.4 probability of defect. That is the mean. And we can thus conclude that the null hypothesis must be rejected. Visualization number 2, comparing two groups. On x-axis, we have the fraction of teams that are home run hitters. On y-axis, we have the number of home runs. We also have two bell curves. The red curve represents the minor league team, and the blue curve represents the major league team. The research question is: does the average major league team have more home run hitters than its corresponding minor league team? The null hypothesis states that major league home run hitters per team equal minor league home run hitters per team. The alternative hypothesis is major league home run hitters per team do not equal minor league home runners per team. The graphic shows that the major league has more home run hitters than its corresponding minor league team. Then the null hypothesis is rejected. Visualization number 3, efficiency comparison. We have two teams. The blue team, a single queue with single servers in sequence, represented by the blue curve. The red team, the single queue with multiple servers in sequence, represented by the red curve. So now, the research question is, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiency? The null hypothesis says there is no mean difference between the red and the blue group. The alternative hypothesis says there is a difference in mean between the red and blue groups. Now, from the graph, we can see that the mean of the red curve is not equal to the mean of the blue curve. We can then conclude that the null hypothesis is rejected. A German study tested how larger industrial use vans utilize gasoline. One of the analyses plotted miles per gallon versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlational test and found a significant correlation. However, they forgot to state the hypothesis test in their published paper. Important question. What were the study's null and alternative hypotheses? Null hypothesis. The null hypothesis here is there is no relationship between miles per gallon and the weight of the van. And its alternative is there is a relationship between miles per gallon and the weight of the van. Looking at the graph, we can see that the heavier the van, the lesser miles per gallon. So there is a negative correlation here. So the null hypothesis have to be rejected. Takeaway: creating hypothesis tests. Hypothesis testing refers to the formal procedure used to accept or reject statistical hypotheses. Null hypothesis is a hypothesis set up to be rejected in order to support an alternate hypothesis. Alternate hypothesis is the opposite of the null hypothesis. It is a statement expressing a relationship between two variables or indicating differences between groups. Using visualizations. By visualizing, we are able to gain valuable insights from our data that we couldn't initially see from just looking at the raw data in spreadsheet form. Graphics plots and charts provide a nice way for us to get a sense for how quantitative variables compare in terms of their center or mean and their spread. Thank you for watching my presentation. I'll be taking questions.